This is a tutorial for this simulation called Free Body Diagrams and Inclined Planes. Now, this simulation is actually quite complicated, but you can actually use it to create some interesting pulling force problems, and it will also give you the answers. Now, when you load up, it might look like this. My calculator is currently showing. I'm actually just going to drag it over here to discard it. It starts off with a square box, and at its most basic, you can just draw basic free body diagrams for it. Because the simulation is complicated, I actually do give tips, which you can remove here, but I'll keep them on for a moment. If you hover over, you can see the tips say force box. Click and drag from the center to add a force. Clicking off center allows you to move it around. Clicking the red corner allows you to change the size. And if you click in the middle, you can just drag and make a force arrow. And once that force is highlighted, which you can highlight simply by clicking on it, you can see that red outline. This highlights the object. But if I click on the force arrow, I can change the size. But it also opens up a whole bunch of labels. So if you want to call it F1, or maybe this is just the normal force of the floor, you could call it Fn. I can create a second force and call that Fg. And you guys get the idea. We could call that one, maybe that's the applied force. Maybe this one's kinetic friction. Or maybe the applied forces, you can see you can drag the labels too. Maybe the applied force is on an angle, so the normal force is larger. You could have students draw these FBDs. If you find some of these things like the mass and the label obtrusive and you don't want them on there, you can actually go over here and deselect mass and deselect ABC, and it will remove them. And if you want to, you can drag the whole thing around if you need to make more space. I'm going to add those back on for now. If you select one of the objects, you can see that orange circle around the square here. It allows you to choose different, if you want it to be an anvil or different emojis or Superman or Wonder Woman. Or if you want Superman to face the other way, you can click this if that's more important for you. So those are the options for the square. You can make them bigger or smaller as well. Okay, I'll reset. This circle is pretty much the same, but if you want a circular shape. If we wanted to incline planes, you can actually drag this inclined plane down and you can adjust the angle. If you want a very exact angle, you can force an angle, and I'll show you how to do that in a minute. But generally speaking, it will just adjust the angle correctly to whatever you want. You can also move the top, and you can create, of course, a second incline on the right side. Now, you can add forces on the inclined planes if you like. Let's make this bigger. So you could draw, you can see I'm going straight downwards, and I've got this kind of default mode where it will automatically resolve the gravity into the perpendicular and parallel components. So that kind of happens automatically. And if it's on an inclined plane, it's got kind of a snap function to automatically be parallel or perpendicular to the actual plane here. Now, one of the other cool things I can do, drag the center of a box. Oh, right, if you want to get rid of a force, you can just drag the tip down into the box and it will remove the force. Almost forgot about that. Also, if you want to move the labels around, you can click and drag on every label. So let's try to grab the tip there, and we'll get rid of the force of gravity one. Another cool thing you can do, but let's make it a car. Let's make it a car facing, maybe the car is going down the ramp or something. Make it a little smaller. Get rid of the ABC. Another cool thing you can do about this is if you click on show acceleration, it will give you the acceleration for this car down this ramp. And if you want to add a mu k, you guys can see there's a mu k here. I could just make it 0.2. If you click here, show mu, it will put the mu k right on the diagram, which you can drag around if you want. And you can see that's changed the acceleration. And, if the mu k gets too big, it'll even tell you the object does not move. If you want to manually adjust the mu k, you can actually use a calculator. This is kind of cool. In the bottom right, you can grab this calculator out. And if you click on mu k, like that, if you click C, it will say enter value, and then you can make your mu k 0.31. And if you want to make the mass of your car 1,500 kilograms, hit clear and put in 1,500, and then that's what you have. If you want to have an exact angle to solve your problem, then you can edit the angles. But this does give you the option of giving it not the correct angle for the diagram. Like I could hit clear and I could say that's 65 degrees. And it will give me an answer that is appropriate for 65 degrees. It just doesn't match the diagram. So that's why I made that a separate option here for edit angles. Okay. The other thing you can do is you can add a pulley on this one. So if you click on the pulley, you can add a second box here. And of course you can edit, oh, it's a bit awkward. You can, what's happening is the box is on top of the calculator and it's grabbing both at the same time. So I'll just move the whole thing over and I'll get rid of the calculator for now. You can edit this box and you can see now the objects don't move. Or I can move the friction down to 0. And now, of course, the 1,500 kilogram car will, of course, outweigh the 10 kilogram box here. Or we could change that mass to make it a little more realistic for this problem. Maybe we'll make it a 20 kilogram mass. Okay. On the we could have this like Wonder Woman, you know, pulling it downwards or something. You could also have an incline on that side, and you could add a separate value for friction with your calculator. We could have a separate, you know, 0.14 on that side, and now it will tell me that this whole system is going to accelerate 0.69 to the right because Wonder Woman is now outweighing the Honda Civic or whatever car this is. Now, if you wanted to just have a diagram of this and sort of screenshot it, I made a system to allow you to do that as well. Let's get rid of the calculator. You can keep the masses or get rid of them. You can show the mu's or get rid of them. You can show forces, as in like the triangles, or you can just choose not to show them. Get rid of the answer, or get rid of the tips as well. If you click on pick, it will kind of clean up the image in such a way where you can take a nice screenshot to put it into your Word document. And if you don't like the placement of any of these values, you can just move them over. The last shape that you can use is just kind of a double pulley. So you can see the options are gone from the bottom. That's because we're still on pick mode. If you get rid of that, it gives you the option of adding that second pulley. And you can do any of those same adding forces, changing the mu, and showing the acceleration. Here we can see that it's going to accelerate left because there's no friction. So that is this simulation. I hope you find it useful.